Good morning, everyone. My name is Dave Whiteley. I'm Technical Director of Envisageukltd, and I'd like to take this time to show you multi-body modelling within Autodesk Inventor. I've got here a sheet metal part. It could be any part. In this instance, it's sheet metal. And we've got, I want to create some tooling to manufacture this sheet metal component. I'm going to show you how we can do this in multi-body modelling. The techniques I'm showing you today can be used in many, many other designs, not just for sheet metal parts. This is just another example to add to our list of YouTube videos that we've created already. So the first thing I want to do is to make a derived component of this sheet metal part. You cannot do multi-body modelling within sheet metal parts, and it's not advisable really to do any multi-body modelling within a part that you may want to use elsewhere anyway. So what we're going to do here is go to Manage, and we'll make a part out of this sheet metal part, i.e. a derived component. This will make this into an IPT single part file. So we'll just choose the fact that we want the solid body to come through. We'll give the part a name. And in this case, I don't want to place it in a target assembly, because the idea of multi-body modelling is to actually model within a part file and create, say, like a pseudo-assembly within the part file and push that out to its assembly later on. So we're working within a part file. So this is going to take this particular solid body, in this case the sheet metal part, and it's going to put it into a standard IPT template file named MBM9 in this case. And the bill of material structure is normal, and we're not going to place it into a target assembly. Information here is quite useful if you're working with plastic parts. If I need to take a plastic part and send it across to a derived component and take into account shrinkage, I can add a scale factor in this box here as well. Okay, so let's create our derived component. And there's our sheet metal part. Just update it from the original part file. So we've now got a standard part file here, which has got our derived component within it. And as you can see, we can see a folder in the top of the browser here that says that there's one solid body in here at the moment, which is actually this sheet metal part. And I can rename these bodies. Let's just call this sheet metal part or something. And this is where we actually start building up the bodies within this part file. So this is where we start creating this pseudo assembly. So the first thing I'm going to do is just start putting together the tooling underneath this sheet metal component. So we'll just take an offset work plane first of all, and move this up by, say, 25 millimeters. And we'll sketch on here. And we'll start building some blocks that are going to be bolted to a bolster eventually, that are going to nestle around the flanges of this sheet metal part, so that when the press tool comes down within the sheet metal part here, it presses the flanges down around the blocks that I'm about to model. So let's just start a rectangle here. Use the new ability to add dimensions as we sketch, so we'll just add a width of 25. The length is going to come from me setting up collinear constraints from the sketch to the sheet metal part. And the advantage of all this, of course, is we're in a single part file. So all the functionality of using constraints and dimensions are across the board within this part file. So even though I'm about to create another body, i.e. another part in our pseudo assembly, I can still see other parts inside this, or other components inside this single part file. This is very useful. It avoids us having to work with associative adaptivity in assemblies, which can slow your assembly down if it becomes very, very large. So I'm using collinear constraints just to nestle my sketch against my component. And we'll just finish that. And we'll extrude it. Now, I want to extrude this as a new body. So when I use the extrude command, I must make sure that instead of using join, which will add this extrusion onto the sheet metal parts that I'm working on, I need to use the new functionality down here, which is to actually create a new solid. This will now extrude this, but as a new solid body. If you fail to do it and you use join instead, you can always go back and edit the extrusion and change it to the correct function that you require, which is the new solid at the bottom here. Okay, I can now use the sheet metal part to extrude to, because this is a single part file, so I can select the face that I want to extrude to. That will create a new body in our browser here, and I'll just call this tool 1 or something. Now, it's important to name your the solid bodies in the browser here, because eventually when you do push it out to an assembly, it's going to use these names as the part numbers by default. So make sure you put your correct part numbers in these solid bodies as you create them. Okay, let's mirror this block over to the other side. So we're going to use the mirror function. And I'm using the option here to mirror a solid. Now when they say solid within a multi-body solid, they mean a solid body. So as I hover over my part file here, you'll see that it actually notices and it can see that there are actually 2 solid bodies on here. I need this one, which gets highlighted in magenta. And it's important, again, instead of using join, to use the button for new solid. Just give it an origin plane, and that will then mirror the block across to the other side, again as a new solid. My browser here. Okay, I'm going to change the properties of the part file. Each part or each body in this part file can have its properties changed. In other words, the colour. So I'm just going to change this to yellow clear, so we can see what's happening when we turn it upside down. I just need to create the blocks on the other side. So again, let's just sketch on this work plane and draw our rectangle. I always like to, when I'm sketching in this sort of process, I always like to draw my geometry away from the components that I'm going to constrain to, so that when you actually use constraints, and this is a tip that I can give you for most sketches, when you then use constraints, the sketch will actually jump into position. If you've drawn it in the right place in the first instance, you may not be sure that the constraint's actually happening. Okay, let's extrude that one, again as a new solid, to the face on the underside of my sheet metal part, and again we'll mirror it as a new body to the other side, and we'll just rename these. Okay, now we need the bolster. So again, we'll sketch on the work plane here and draw a rectangle representing the bolster. Let's put some dimensions in. And we'll centralize it. I've been very careful all the way through, making sure that 0 is at the center of my bodies and parts, which makes life a lot easier when it comes to constraining. We'll just align these vertically and horizontally to the center points. And then we go ahead and extrude this sketch, again as a new part, a bit of thickness. Okay, so there's our bodies created. Let's just turn off a few things here so you can see it a little bit easier. And we'll call the last solid base or something. Okay, you can turn off the visibility of bodies separately. In this instance, we can just turn off the visibility of the sheet metal part. And now we need to drill some holes. Again, because this is a single part file, the holes are very easy to drill. I just need to set up some sketch geometry here, project all the faces, and we'll just draw a couple of rectangles representing where we want our holes to be. Again, we can align these in relationship to the geometry, just to center them, and might as well center that or align that with that one there, and that one there, just to center these on the components. I always want to future-proof my designs so that if anything changes, I know that it's still going to work. So all these lines are in the middle of these side plates here, and I know that if I change any dimensions, I know this sketch is going to work. So always future-proof your sketches. Just need to add some dimensions here. Let's make that one 30 mil, and that one the same, of course. That's mirrored, so we don't need it that side, quite right. And then dimension there, and we can choose that dimension to make it the same. Good, so let's finish that sketch. Go to the hole command. Now, the hole command needs centers and solids. When you're working in a single part file, as soon as you select a point on a solid, that gets selected automatically. As you can see, the arrow's gone white to show that the body that I just selected a point on has been selected as well and highlighted in magenta. But what I'm going to do is I'm going to go around and select all the corner points. But as you can see, I'm not getting a preview on all of these. I now need to go to the solids button and choose the other solids that I want to drill holes in. Once I've done that, you'll then see the preview of all the holes being drilled on those solid bodies. Now, because I've got through all here, it only drills through the bodies that I've selected. If I want to drill these holes all the way through the bolster as well, I would have to select that as well. But in this case, I don't, because I want counterbored holes at the top, threaded holes in the bolster. So I'm going to choose this to be a counterbored hole all the way through the bodies that I've selected. So in other words, not through the bolster. We'll choose the option to get a clearance hole for an ISO fastener, a socket head cap screw. Let's choose M10. See the preview on the screen here? Click on OK. That drills all our holes. So those holes are drilled in each individual solid body. If we take a look at one of these solid bodies, you'll notice underneath we can actually open this up to show what features that I've been using so far actually are part of that particular body. So I can actually edit features underneath a body here should I wish, as opposed to the list of the sequential features that we've used as we've been modelling throughout this component. Okay, we now need to do the tapped holes in the bolster, so let's just sketch on the top there and project counterbored holes. And finish that sketch and then add holes to that solid, that bolster, select the center points. Oops. Okay, he's going to be tapped. M10. All the way through, but again, all the way through, just what I've selected. There's the preview. So it's only the bolster, the component that's, or the body that's highlighted in a dotted magenta line type here. This is the only body that's going to be drilled all the way through. Okay, so there's our finished design. Let's just put a few chamfers on as clearance for the sheet metal part as it's folded around here. So we'll just pick the edges. And notice, because these are separate bodies, how the edges have been selected. Okay, so the chamfering is working as I want it to work. Just accept that. And that's the finished IPT file the IPT file's been finished with the relevant bodies created inside it. And of course this is a single part file, so it's no good to us in an assembly as such, and it has no parts list or bill of materials. So what we need to do now is to push this out to an assembly. So we go to Manage for this and Make Components. And the first thing we need to do is select the bodies that are actually going to go through to this new assembly. So this, if I had also modelled the other side of the press tool here, I would just choose, for instance, in this case, just the bodies for the base of the press tool, and then I would do a separate assembly to do the bodies, or to choose the bodies for the other half of the press tool. And as you can see in this instance, I'm not choosing the sheet metal part because I do not want it in the assembly. It doesn't have to be, the visibility doesn't have to be turned off to do that. In this case, the default is to insert the components into a target assembly. The name of the assembly is taken from the name of the part file. This can be altered, of course. If we go on to next, it then gives us a list of the bodies as we named them in the part file, a list of how it's going to name them as IPT files. The reason why I've got _2 after these is the fact that the original IPT files, tool1.ipt, already exists in my folder, in my work folder, so it's automatically added an increment to the names of the part files. But these can be changed in here. You can overwrite these and call these whatever you like. What template do you want to use? What bill of materials structure? You may want to change this to purchased, for instance. And the source path is as per the workspace you're working in. So if we click on OK on that, that will now create us an assembly with all our parts in this time. So we're now in an assembly file with all the bodies converted to part files, with a push pin on everybody, because of course you don't have to assemble this. The assembly is actually done within the part file. The part file decides where everything is placed, so you don't actually have to assemble anything. There's nothing to stop you ungrounding these and reassembling them should you wish. The canny ones amongst you will notice, for instance, that these parts are actually the same. So I could actually take 2 of these side plates off and just reassemble the duplicates, if you like, so that then in the parts list we actually get 2 off of each. I'll leave it as it is at the moment. Okay, we need to add some fasteners. So let's go to Placement Content Center. Choose my fastener. I'm going to use auto drop. Auto drop, what this does is, because it's asking me to select a circular hole edge, as I select a circular hole edge on my model, it goes through and finds the fastener that's the correct, that fits this hole to the correct fit. This is an 11mm hole. This is bringing me in an M10 fastener. The red arrow at the bottom enables me to adjust the length of the fastener using standard length fasteners. And you'll also notice that because on this part there's another hole, it's highlighted in red as well to show that when we add the fastener, it's not only going to be added to this hole, but the hole on the side here, which is coplanar to it, which is the follow pattern option here. So let's accept that, put the fasteners in, go around and choose the next one, the next one, and the next one. So there's our fasteners in our assembly. And then if we save this, we'll create a quick drawing of it. And our base view. Okay. And let's just choose a scale just to reduce this slightly. a few views on the screen. Let's just change that one to shaded. And we'll add a parts list. So as this is now an assembly, we'll be able to take a parts list off of this. Giving us the quantity of components within our assembly. And then finally, balloon, perhaps this isometric view here. And there we go, there's our drawing finished from our assembly. Now if I go back to the original sheet metal part and change this in some way, okay, we'll go to our multi-body modelled part and update it. We'll go to our assembly and update it, and we'll go to our drawing, and that's updated already. So as you can see, we've got the ability of running from a single part file through to a multi-bodied part file, where, as you can see, it's much quicker creating an assembly in a single part file there in a multi-body, push it out to an assembly and create a drawing from it. So the whole idea of multi-body modelling is to be able to model an assembly as a part file initially, where in your head, if you take a look at the mouse that's on the desk at the moment, if you wanted to model that mouse up, it's so much easier modelling that as a single part file first and then pulling the assembled parts off of it later than having to model all the parts up separately and assemble them afterwards. So the whole idea of multi-body modelling is to get the idea across straight away, either as a single sketch or, as I've done in this case, a derived component, and then work off of that and use the functionality that you have in a part file of accessing dimensions in the part file, other edges in the part file, other faces in that part file, and to be able to model bodies very quickly that we can push out to an assembly later. So that ends our webcast for today. There's my contact details should you wish to ask me any other questions on this, or there are any videos or webcasts that you would like to see in the future. Have a good weekend, and thank you very much for attending, and I'll hopefully speak to you again soon. Thank you.